Hi everybody, my name is Caitlin Ariola. I am a freshman here at USC. I am a math peer mentor for MESA University, and today I'm going to go over ultraviolet voodoo, which is more commonly known as integration by parts. So I'm going to start by writing our problem, and our practice problem is a little bit more on the simpler side, but this topic or this integration technique can be applied to more complicated topics. The formula itself is the same. So the formula for integration by parts, which is why it's more commonly known as ultraviolet voodoo, is uv minus the integral of v du. Now, to identify what your u and your v and your du are going to be, is going to be a phrase known as liate. There are other phrases that you can use. The one that I most commonly use is liate. And the L stands for logarithmic, I is inverse trig, A is algebra, T is trig, and E is exponential. When I say algebra, it's algebraic functions, so the functions that are like quadratic, etc., etc. In this problem, we have an algebraic function, which is x first. So since our x is first, that is going to be our u, which leaves our sine x to be our dv. When we find our du, we just take the derivative of u. So the derivative of x is 1, and when we find v, we take the integral of sine, the antiderivative, which is negative cosine x. All we have to do now is plug it in to our equation, or our formula, if you will. And now we can simplify our function. The negative will turn into positive for the integral. And the integral we have now is a lot more easier to do. The antiderivative of cosine x is sine x. So our final answer is going to be negative x cosine x plus sine x and plus c. But there's another way of doing this. It's similar, it's a lot shorter, and some people find it a little bit easier. It's called the DI method. So what I'm going to do is I'm going to use a new equation or a new problem for this specific method, considered a little more harder, but the concepts itself are still the same. We're still going to have our liate. That's still going to be a way we're going to identify what our, in this case, d and I are going to be. So the d for d is going to be like our u, where we take the derivative, and the I in the I for the name is integral, like our dv. So we're going to start off by identifying our d and our I. So it's kind of similar as the last problem. We have an algebraic first, which is going to be our d, and then our cosine x is going to be our I. So we're going to start off by creating a table. We're going to label it d and I, and we're going to have a column on the side that's going to start off plus. So it's going to be plus, minus, as many times as you like at the beginning. Then we're going to write our initial function. So we're going to write our, that's a good note, always start with positive, always start with a plus. But we're going to write our initial functions, our d as x squared and our I is cosine x. And what we're going to do is we're going to start on our d side. We're going to just integrate, and we're going to take the derivative like normal until we hit 0. Then we're going to take the integral of cosine x until we reach that same 0 mark. That will be 3 more times. And what we're going to do is we're going to go diagonal. So we're going to go from x squared diagonally to sine x. We're going to go diagonally from 2x to negative cosine x and diagonally from 2 to negative sine x. However, the signs on the side that are along the D column do not change. Those go straight across, and those apply to the term in the D column. So when you combine all the terms together, you have to take into account the sign that is on the side. So we have a positive x squared and a positive sine squared. We have a negative 2x and a negative cosine x. That's going to turn into positive. And we have a positive 2 and a negative sine x. So that's going to be negative 2 sine x. And we can't forget that plus c at the end. And that's your final answer.